Welcome back, grade 12. Today we're going to be doing a lesson on how to create the detailed drawing and dimensioning for the valve body. Now I'm going to be cleaning up some of this dimensioning. Now a lot of this dimensioning isn't bad, but it could be placed a little better than what we see here. And for example is dimension extension lines that are crossing over ordinate dimension lines. And basically a little bit of unnecessary crowding. And we're going to be improving on how we do the thread and hole callouts on this drawing as well. Now we will be creating the right-hand sectional view, and we also will be creating some of the dimensions you see here, but we're going to, again, I'm going to improve some of what you see here. So a lot of this is good. It just needs a little bit of refinement. It's a little crowded. And so we're going to be, cleaning this up. So I'm going to be clicking into the valve body, and I'm going to just, the front view is currently identified as the right view, so I'm going to hit the down arrow on the cube, and I'm going to set this current view as front and hit save. Now I'm ready to begin the drawing file. So I'm going to be going to File and New, selecting ANSI Inch IDW from Templates English, hitting Create. Now as you know from the caster lesson in drawing files, it defaults to a D size sheet, so we're going to want to change this. The appropriate sheet for this is one size smaller, so we're going to hit Sheet Formats, and we're going to select C size sheet and hit OK. Now this is going to bring in more views than I really need in an orientation I don't want. So what I'm going to be doing here is basically deleting some of these. All right, so that's what I want. Now I'm a little confused as to why it didn't update to my new front view, but anyway, I'm just going to change it. It says right, but this is the view. This is the parent view here, so we're going to hit OK. And we're going to generate our top view, so right-click, right-click, Create View, Projected. So we're creating our top view, left-click, right-click, left-click, Create. Bring this down a bit, leave some space. And before you create the section view, you should place annotations as required, centerline annotations on the top and front side view. So we're clicking over to annotate. We'll work on the holes first. So we're going to be placing a center mark on the most outside hidden line that represents the thread. And we're also going to be adding one here as well. And we're going to be going up to the top view. We're going to be selecting here. And this hidden circle doesn't, this is drilled out by this front drill, so we're not going to place the center line to the larger one, only the smaller one that's whole, right? We don't apply center lines to circles that are not fully 360 degrees in a circumference. We're going to do these ones. And we're also going to be placing center lines here because this drilled hole is round and so are these threaded holes, right? So we're going to, this time we're going to go by sector here. We'll select these two lines. And then because these extend, because this drilled hole basically extends, what we can do is we can hit cancel, and then just stretch this out a bit to here. And then we have to do the same thing here, right? But if I stretch that one all the way down, it doesn't look like a center line. So what I'm going to do is just create another bisector one here and here. And that's going to give me that intermittent dash. And because this is a blind hole in the middle, this should be stretched out a little further to indicate that this is a cylindrical object in the middle here, right? And I don't need to worry about extending this center line up beyond the top surface or this one below the bottom surface because I'm sectioning through it, and the section line is also going to, that section line is going to supersede the center line. It's going to be going over top. It's quite thick. But what I do need is a center line going through these holes here, because as you know, those are the hidden detail lines for these 4 holes that's seen in the top view. So again, we can use a bisector, and we're going to be selecting this line and this line, and this one and this one. And we'll just stretch it up accordingly. This goes all the way through, so we're going to pull it just beyond so it's even, right? So make sure you take care when you do this. And that should be it. We could stretch this center line to here, but again, I'm not going to, because this, I don't want to misinterpret symmetry, right? This base, only this part here is symmetrical, but because it could become misunderstood, I'm just going to leave that center line the way it is, and it should be fine just like this. All right, so I've got all those in place. These hidden lines, the center line would go between to represent symmetry, but again, the section line will overwrite it. So let's create the section view now. Going to place views, selecting section, clicking into this view, and finding the midpoint of the top, and then just bringing my mouse up. I see that little trail of lines here, so now I'm ready to click. I'm going to click down and then click into a similar position underneath. Left click, right click my mouse, and left click continue, and this will create our right hand sectional view. And that looks like this. So everything worked out like it should have. All right, so now we're ready to begin the dimensioning process. And I'm not going to, get into a heavy lesson about it. I am just going to discuss some things about it as I go, and just to kind of, explain some things. And we try to keep dimensions from not going between views when possible, but that's not going to be possible here. We're going to have some dimensions going between views. There's just too many to place on here, but I'm going to try to keep it to a minimum. There's going to be a thought process on how I do this. So to begin, we're going to be placing the first dimension here. I'm going to start with the top view, click to this center line, and create the 1.25. I'm going to drop it right here. Now this dimension is shown on between the views in the other handout that I used to draw this, but again, I'm making some minor adjustments, trying to keep things from between views when I can, right? We try to keep dimensions from outside of views if possible. We only put them between when when there's an actual advantage to do so. So there's going to be our 2.5. That's in the same position. And moving onward, we're going to be showing a dimension from the center line to this center line. It's very important that you place the center lines first before you start placing dimensions, because the dimensions are supposed to have a gap. They're not supposed to, go all the way to the center of the circle. And then when you put the center line on, it covers it and there is no gap. And we don't know where the center line and the dimension extension line starts and begins. So I'm showing you the correct way to do this. Now, because I don't have a center line passing right through this, I would like to add a typical here, because this is going to let the person know in the shop that it's going to be the same down here below. And I may just pull that out a bit, leave a little more space. I'm trying to use the tracking system when I place the dimensions to make sure that this looks proper. Now, we need to know, and a lot of these dimensions are seen on the sheet. So I'm going to the center line here, and I'm coming out to here, right? We're trying to keep the spacing looking nice and consistent. We're also going to place a dimension from here to the front, and that's going to be 1 inch. All right, we also need to identify this radius as well. Oh, sorry, not the radius, but the diameter of these 4 drilled holes. So dimension to here, I'm going to place this one in line with this one, as you can see. And then again, instead of saying 4 places, I'm going to say typical. And then that's going to let the person in the shop know, yes, I need to use the same size hole 4 times. So that lines up very nicely, right? So we're off to a very neat, proper looking start. Keeping dimensions outside the views, keeping them from between views when we can. Again, it's not going to be possible. So I'm going to need to show that this length is 3.25. Now I can show it on the top view or the front view. It really doesn't matter. It has to go between 2 views because I have nowhere else to put it. I don't want this extension line to run from here to here. This way it could be confusing. So I'm gonna put it between 2 views for clarity. And I'll just do what the sheet does, and I'll keep it on the top view. Right, that dimension's not in a bad place, so I'm going to leave it as is. Again, if I ran it back here, it could become confusing to the person because I'm really attaching the dimension to here, and this actually is an extrusion separate that extrudes into the front face of this part right here. Right, so there's my reasoning. Now, because I've identified this as a typical dimension, I really don't need the 1 inch that you see here. So I think that's over dimensioning. So I'm going to leave the 1 inch dimension out. I am going to place the 2 inches, not the 1 inch, but the dimension here to here. This is important. We need to know how large this is from top to bottom. Okay, I just want to move this. Okay, that's too close. I just want to keep it fairly consistent, right? I'm taking care to make sure the spacing looks the same. It may not be exact, but it should, to the naked eye, it should really look the same. We keep the first dimension a little further, and the next dimension is a little closer, and then the next one will be the same distance between the first and the second one. All right, we have to identify the diameter of this hole that passes through the top to bottom through. So that's a dimension. We're going to select this diameter, and we're going to try to keep this in line with where the 2 inches is. So about there. Right, that's a good spot for that one. I need to keep this one low because I have a couple of dimensions I'm going to have to place up here, and one of which is the radius of the base. I'm going to attach that dimension here, and I'm going to place it about in line. The R is in line with about the 2. Right? Keeping a similar distance to what we see at the bottom. Click OK. All right. That's about all we can do with the top view for now. Now we do need to dimension this hidden feature. Of course, I'm not allowed to dimension to a hidden line. So what am I going to do? I got a problem that I'm going to have to solve by the time this lesson is over. So I'm going to be coming back to that later. Let's take a look at the front view. All right, I'm going to need to dimension where this hole is from the center here. Again, this is 0.5 again, but it's not a typical because this is something different. So we're going to add tip though, because it's going to be the same here as well, and on this side and this side. So let's try to keep this the same, right? Next, we need to know from this surface to this center line. We'll drop that dimension right there. That's 1 inch, right? There's a center line here, so it's indicated that it would be the same on this side. I'd rather have an overall dimension than another 1 inch here. And so we're going to dimension from here to here, and then add the 2 inches. Right? We may just make that look a little nicer there. All right. What do we have next? Well, the sheet shows a dimension from the center line here of this threaded hole to the middle. Of course, the section line is going to interfere. So I don't think it would be any harm to run a dimension from here to here and place it there, right? And then also, this is also typical, right, to the other side. And there's also a dimension running from here to here, this 1.63. We'll bring it a little closer. Again, placing dimensions between views, right? I'd rather run the extension line for less than more. You know, I'd rather not run the dimension all the way to the bottom here for both these things, right? It's just easier to see. Like, this is closer to the top of the front view, so I'd rather place the dimensions here, right? These dimensions aren't overly crowding, right? There's a good space between them, so I'm gonna call this acceptable. And I'm going to have to put one dimension down here, and the sheet does the same thing. It's the distance between this hole and this hole. It's showing as 2.26. Now on the sheet it shows 2.25, so that's something else I need to fix up later. So I'll come back to that. So what do I have left to do? I need to identify the hole callouts. And we're going to be doing this in a different way than we've done before. We're going to be doing it a little more professionally. So one dimension that I need to do is show the diameter, this 1.25 diameter that gets drilled a certain depth, right? It gets drilled 1 inch deep. So what I can do is, instead of running the dimension, I can run the hole and thread. This is annotating in a more professional way when we use the hole, because we used hole features in Inventor to create this. So if I select hole, I select the hole, look what it does. It runs the diameter for me, and it also, I'm going to keep this in line with the 0.5 about here. And as a little arrow, this means depth, right? So this already does this for me. It lets me know the diameter. I don't have to actually physically type a note on the end. 1.25 diameter, a depth of 1 inch. So that takes care of that. We also need to identify the radius value, so I'll use a dimension for this. Run a dimension, and this, we'll keep this in line with this one up here. And this is typical. There's about 8 of these, right? They have it dimensioned twice on the sheet. I don't think it's needed twice. We'll just say typical, and we'll call it a day. Because it should be obvious that there's 4 here on the front view, and there's 4 on the top view. So that will take care of that. And we also have a thread call out. Here we have 4 holes that are drilled and tapped. So what we'll do, we'll see how we can run this dimension. We'll go, again, this is going to be hole and thread. And I will select here. All right, so what this is giving me, it's saying 7/16, 14, that's 14 threads per inch in a unified national course thread. 2B, that means hole. If it was A, it would mean physical shaft. And the depth is 0.88, which is the depth of the thread. Now, I'm not totally satisfied with this because it doesn't tell me the size of the drilled hole and how deep we went, which I think is important. So we're going to double click this, and we're going to hit the tap drill. And look what that does. It updates it. So I want you to include the tap drill, what I've just shown you there. So that's going to show that we have 0.37 hole diameter. We drilled it 1.25, an inch and a quarter deep. Then we tapped it with a 7/16, 14 unified national course thread. And that's about 0.88 is about 7/8. So that makes sense. Right? We got more dimensions between views here. I guess what I could do, could I sneak that dimension in here? I don't want to run a lot of these dimensions on the left to keep them between the front and the right side view, because I want to avoid running extension lines over ordinate dimension arrowheads if possible. So if I was to rerun that dimension here, like, it doesn't really fit, right? And then I'm going to have to cross over these extension lines, you know. I guess this is okay. You know what? Let's just leave it like this. We gotta have a couple of dimensions between views. We're gonna have to live with that. I think it looks fine on this side. So there's care in the creation of these. So that takes care of that. Now the right side view is pretty much going to be left the same. I really agree with the dimension that's found here, because that dimension is in the best possible spot. Of course, it has to go between 2 views, because this is where that feature is located, but it's easier to understand that 0.10 on the right sectional view, right side sectional view, than it is to run the dimension here, because it's always easier to understand these dimensions where you see a clear profile of the feature, and that is found on the section view right here. So I like that dimension. That's really, really good. All the rest of these dimensions I can keep on the outside here, which is preferred, but I'm going to change a couple of things. I really don't agree with the way this is dimensioned here. This is not helpful for me to know that from here to here is 0.25 and from here to here is 0.5. I really only need to know the 0.5 and the actual position of where it starts at the top surface. So I will run a dimension from here to here. This is better. This makes more sense, knowing where this starts from the top surface. And now I can run a dimension from here to here. That 0.50, yes, that's important to know the thickness. And I also need to know the thickness of the base as well. We're going to run that one outside a bit. I don't want it to be too close. And we also need, instead of a general note of the fillet, which is found in all these, this little fillet, this little baby 0.100 thou fillet, we'll just run it here once. Oop, that didn't work out. Try that again. Zoom in. And keep this in line with the R, with the decimal 4. Don't crowd it, a little bit of distance. And then add tip, because that radius is found in lots of different locations. One last thing that we need is an overall height. We need to know how tall the valve body is. So I really agree with this dimension as well. That dimension is required in a very good spot. All right. So, taking one last look at this, I do need an isometric view in the corner. Create view. Let's stick it up here. Scale it down to 3/4. Okay. I think I have all the dimensions that I need here. Yeah. I will add one more here. I think that's important to have as well, because we're not really showing that overall up here. We're just showing the radius value, and I think it's better to have this shown here. I think that's important. We want to have overall dimensions. Okay, we'll just move it up a bit so it's kind of consistent with the spacing. Now, here's the issue. I've left one dimension out. How the heck do I dimension this hidden line? I have no good opportunity to give the actual radius of it. I don't want to, because it cuts into it here, so I can't really use the sectional view. So I'm going to do something new here. I'm going to do what's called a breakout view. So while I'm in annotate, there's a sketch. Create 2D sketch. So I'm going to select the 2D sketch, and then I'm going to go over to sketch, and I'm going to select a spline here. I'm going to pick up a place to start, and I'm going to draw a little spline here. And once I've drawn that sketch, I'm going to hit Finish Sketch, and then I'm going to go over to Place Views, and I'm going to find Breakout. I'm going to create a breakout sectional view here. Select Breakout. Oh, this isn't working. Oh, here we go. Okay. So hit Breakout, select the sketch. The menu will pop up. The profile is selected here. And we're going from a point. So we're going to come down to the parent view, and we're going to select depth here. Right there. That's where that feature is on the parent view or the front view. Then we're going to hit OK, and it's going to create that breakout section. It's not going to include the spline where there's empty space, but it basically just creates a section here and allows that part of the hidden line to become object line. So now I can actually run the dimension. This is allowed now. I'm not dimensioning to a hidden feature. And I'm going to have to cross over, unfortunately, an extension line here. Like, it's just unavoidable. There's just too much going on. But that is how you dimension this. So that's something new, creating the breakout section with the point. Now, before I continue, I'm going to fill in the title block. Let's fix my name up. All caps. Title. Valve body. Subject, okay, company, Ancaster High School. Project, part number. This is our second drawing file this semester. So this is 4M1-02. Revision number is 0 because it's the original. And we're going over to status, the checker. I've got my checker all ready to go. Who's going to check my work? You should have a checker as well. The date they're going to check it. Apply and close. Let's check this. Rev 0, drawing number, C-size sheet, valve body. We got everything we need. And the last thing I'm going to do before I end this lesson, I'm going to save this actually. Yes, I do want to replace it. I want to fix this 2.26. If yours is like this is how you fix it. So you go back to the model, you find that in the project browser which hole that refers to. So this is hole number 1. Right click, left click, edit sketch. And then these two dimensions here, now depending on how you did this, I'm just going to edit these to be a little more precise. I'm going to make this 1.125 on each side. And then update, finish sketch. That's going to just move those slightly. Save, go to the drawing file, and look, everything is updated. 2.25, done. So that is my interpretation of how to detail the valve body. I think it looks really good, the way the dimensions are positioned. I think it's a much cleaner way of doing it than what you see here. And it's similar, very similar to what you see here. A lot of the dimensions were good. It just needed Mr. Lemieux's touch of experience here. So at this point, I'm going to end this lesson. This is going to be your activity for today. Complete the detailed drawing as you see here. Save it, create the PDF version, and you'll be submitting this to the assignment folder Dropbox. Good luck, take care for now, and I'll talk to you later.